So let me erase all that real quick. So to solve quadratics, we have to learn about other types of solutions. Sometimes when you solve a quadratic equation, you'll get no solution. So remember I said sometimes you'll get this no solution thing. And what does no solution mean? Well, mathematicians came up with a solution. They said there's got to be a way to solve a quadratic. And it's called an imaginary number. Okay, so this is going to throw you for a loop. Imaginary numbers. They're called not just imaginary numbers, they're called complex numbers. Okay, so it's kind of confusing to make a connection to why a number is imaginary. But basically it goes like this. So I mentioned quadratics. I shoot an object. I'm sitting in an army tank right here. There's my army tank. I'm going to shoot an object. It's going to fly through the air. And this object needs to fly 2 miles away. Well, why don't you just shoot it straight? Why don't you shoot a straight line? Well, I don't have a laser, right? So any object that flies through the air, this army tank projectile, I'm going to hit my target right over here. It needs to fly 3 miles in the air, okay? And the other reason why I talk about this is because I was in the army. My brother was in the army for 7 years. He sat in an army tank and he shot projectiles. And so he had to go back and learn some quadratics math. And who did he call? Called me. He's my older brother, so they called me about quadratics. And so he had to shoot projectiles and hit targets in Fort Sill, Oklahoma. Anyways, there's the path. So I got a starting point and I got an ending point. This quadratic right here, it intersects the x-axis twice. So that's what solving quadratics is all about. It's finding the solutions. When we solve, we find a solution. Okay, so solving solutions. When we simplify, we simply simplify. Okay, there's no solution when we simplify. Like if I do this, I go x plus 3x. Solve that equation. Well, it's not an equation unless it has an equal sign. So I go equals 12. Now I can solve it. What number solves that equation? But when I do this, I can only simply simplify. Okay. So anyways, I'm solving quadratics with a quadratic formula. But what if I have a quadratic? Oh, I have a quadratic that looks like this. This is a common quadratic. Oh, it looks like that. Let's solve it. It has two solutions. It crosses the x-axis twice. But occasionally, we'll solve quadratics that go like this. And we'll go, wah, 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 no solution. Finite. Okay. Well, there is an answer. There is a solution to that. And it's a complex number. And I'll show you. We're going to learn about the quadratic formula. Might ring a bell, but we're going to do that a little bit later. But I was doing this to introduce why complex number. Okay. So x squared plus 4x plus 12. So whenever we have an equation, there's an equation that has an equal sign when it equals 0, y 0. This horizontal line is the line y equals 0. So this is a quadratic equation that I can solve. So it's solved by factoring, or I can do the quadratic formula. Well, no, you can't solve that quadratic equation. It's not solvable. When you solve it, you'll get a no solution. So this quadratic has a y-intercept. This is the y-intercept of 12, which is way up here. This is the y-axis. So I'll have no solution. And then we're done. Well, that quadratic does have a solution. It's called an imaginary number. So when I plug imaginary numbers into x, like I can try numbers. Let's try a number. Let's try -4. Okay, plug in -4 squared plus 4 times -4 plus 12. 16 minus 16 plus 12 equals 0. Oh, that's 12. 12 equals 0. No solution. This might have a solution. I just made one up. Okay, a quadratic. It could possibly have a solution, but I'm just saying that, let's say it doesn't have a solution. Unsolvable, and we would write no solution. Well, if I plug in an imaginary number, these are called I. I'm going to plug in an I in here. So 2i squared plus 4 times 2i plus 12 equals 0. This will solve the quadratic equation. So we're going to learn about this I business. Okay. For quadratics, they do not cross the x-axis because it's a pure math idea, pure math concept. That's where I comes from. It's called a complex number. Well, actually, I is not complex. A complex number looks like this. 2 times I is not complex. 2 times I is imaginary, but 2 plus I has numbers and letters together. I letter. The I has been reserved for imaginary number. That's why we're doing X's and Y's and A's and B's and M and N's and R's and S's and P's. We never use I, because I is reserved. I have a reservation for imaginary. How about this? So when we solve quadratic, we're going to do the quadratic formula, and we're going to square root 16. Ultimately, the square root of 16 is 4. Well, what if we square root negative 16? We need something for negative 16. We can't just say no solution. There is a solution. When you square root negative numbers, we get I. And then here's the reason why. This is the square root of 16 times the square root of negative 1. 16 times negative 1 is negative 16. Well, the square root of 16 is 4. The square root of negative 1 is what we call I. So we have to use this is why we did radicals last week. We had to know how to simplify radicals because eventually we're going to solve quadratic formula. And the quadratic formula involves a square root. So we have to know how to simplify square roots. Okay. So the answer to this, the square root of negative 16 is 4i. When you square root any negative number, you introduce I. The square root of any negative number is I. Okay. And here's why. Well, 4i squared should make negative 16. So here we go. If square root of 16 is 4, 4 squared is 16. The inverse operation, they work together. This is called a perfect square root. This is called a perfect square. Well, square root of negative 16 is a perfect complex square root, which makes 4i. So if I square 4i, that should make negative 16. 4i squared should make negative 16. How does that work? Well, when you square a number, we're going to multiply it by itself. 4i squared is 4i times 4i. Don't worry, I'm going to get to notes. Okay, this is notes. Okay, don't worry, this is notes. I'm still kind of giving you a preview of where all this comes from. This is equals to negative 16. 4 times 4 is 16. I times I is I squared. Well, guess what I squared is? I squared is, this is substitute. We're going to do lots of substitution today. I squared is negative 1. 16 times negative 1 is negative 16. Okay. Has anybody seen this before? Anybody seen I before? Only a few people? Okay. So it's all new. Square root of negative 1 is I. I squared is negative 16. What about I cubed? Positive I. I'm going to show you why. Okay. What about I raised to the 4th power or I raised to the 5th power? Every one of these has an answer. So in math, there's an answer. Like I always tell everyone, there's an answer for everything in math, except for dividing by 0. Okay. Undefined. So in math, there's mostly an answer for everything until you get to this high level math. So I'm going to go. The square root of negative 1 is I. I is the square root of negative 1. Whenever you see a square root of a negative number, the answer is I. I squared, I'm gonna write it over here. I'm gonna write it out, I'm gonna do horizontal math, so I have room for notes. Well, I just said it was square root of -1. Does everybody see that? So I squared is gonna be I times I. I just expanded. So 2 squared is 2 times 2, 4 squared is 4 times 4. I squared is I times I. So I is the square root of -1. Does that make sense? So I'm gonna substitute this right down here. Square root of -1 times square root of -1. With the square root of -1 times square root of -1. Using that rule, we can go square root of -1, put them both underneath the square root sign because multiplication works that way with square roots. -1 times -1 is +1. Square root of 1 is 1. I squared is 1. That's kind of weird. Square root of -1 is I squared is 1. Well, what about I cubed? I'm gonna break this up into I squared times I. I'm just gonna leave off the parentheses. That's just extra work. You don't have to put parentheses. Well, I squared, this is, we just had 1. Does that make sense? This is 1. Times I. Which is 1 times I is this I. I put a little curly on the I so it doesn't look like an L or something, like you got the dot. I do that with my I's and my P's because we use P a lot, we use I a lot. I raised to the 4th power. Well, that's I squared times I squared. Or you can dice it up any way you want it. You do I cubed times I, if you want to. I'll show both ways. I squared is, where's I squared? I squared is 1. Wait, did I do that right? Trying to look at this. I said I squared was -1. I did something wrong. I gotta check on that. I raised to the 4th. I squared is -1. I did math right over here. 4i times 4i is 16i squared, and I squared is -1. Now, you can see where I went wrong on that? Up there? You don't think so?
Well, if we do it with the exponents, the 1/2 times the 1/2, and then you add them. Right?
Oh, the square root is
Yeah.
1/2 exponent.
So then you get -1 to the 1/2 times -1 to the 1/2, which would be -1 to the 1.
Yeah, if you do fractional exponents, where would the 1? I squared should be -1 somewhere. Because I squared should be -1. I just said that right here. I squared is -1. I tried to prove it. Like I went somewhere wrong with my math. I'm having a brain fart right now. Pause the video. I gotta go edit my TikTok real quick. I'm trying to prove it, but I'm having trouble. Square root
Because combined the negative of the square root combined.
right here. This is where I went wrong.
Yeah, instead of just canceling out. square root of the negative one.
Yeah, I think something right here. I think I can't do that. The square root of -1 is I. I times I is I squared, which is I squared is -1.
this, so we multiply square root of 4 and square root of 4.
Okay, let me try to do that again. Let me go backwards. Delete, mirroring. Okay, here we go. I squared is not I times I. I squared is. Well, we just said I is the square root of -1. Here we go. When you square and square root, the same thing. 3 squared. Square root of 3 squared is 3. Square root of 7 squared is 7. I went somewhere. The square root of -1 is undefined. So I can't square root -1 times square root of -1. That's why I think I went wrong. I apologize. Okay, so the square root of -1 squared is -1. The square root and the square cancel each other out. Sorry about that. I'm looking back over here, I'm like, where did I get -1 from? Okay, anyway. So I squared is -1. -1 times -1 is 1. We got I. We got -1. We got positive I, and we got +1.
I think the positive I, the negative I.
Oh, I squared is -1. You're right. Thank you. That works. Let me double check on that. I squared is -1. I cubed is, and these are things we can just write down, and you can refer to your notes. You get to use your notes on tests and quizzes and all that stuff. I cubed is -I. I raised the 4th is +1. There we go. I squared, I cubed, I raised the 4th. I'm writing this for a specific reason. I raised the 5th power. That's I raised to the 4th power times I. If I multiply these two together, I raised to the 4th times I is I raised to the 5th. Does that make sense? I'll write it out. I raised to the 4th times I. I raised to the 4th is 1. This is I. I raised to the 6th power is -1. I raised to the 7th power is -I. I raised to the 8th power is 1. So you see the same pattern just repeated. I raised to the 5th is I squared and I 6 are the same. 7 and 3 are the same. 4 and 8 are the same. And every multiple of this. I raised to the 9. I raised to the 10. I raised to the 11. I raised to the 12. And it keeps going. If you do I raised to the 16th power. Well, where does 16 fall? The easiest way to count, I'm gonna go by 4s. I raised to the 16th power, 4, 8, 12, 16. I raised to the 16th power is 1.
Well, even exponential is 1. No,
I raised to the 16th power. The car just backed up into someone's car. Uh-oh, better go out there and look. Oh, wait, no. They're backing into a spot. The car was backing up and it like went boom like that. I was like, as I'm looking in your direction, I'm like, the car slammed on the brakes. I was like, oh no. So I parked right there. I was like, they just hit my car. But they're just backing into a space. And there's hundreds of spaces out there. They got to park right there. I was just saying that because today someone told me a story about getting hit in a parking lot and a car backed into them in the parking lot. And I was like, well, there's like, go to Costco and there's hundreds of parking spaces. You just gotta walk an extra 30, like I said, speeding, right? The case for speeding. Park at Costco, park as far away as you can. It's an extra 30-second walk. Can't walk for 30 seconds. Everyone wants to park by the front door. I understand if you're handicapped and all those things. Right? But it's an extra 30 seconds of your life. To park wherever you. And usually when I go to Costco, I drive and I just park in the outer 100, the north 40, far away. And cars are circling, and cars follow me into Costco, and they're circling. Like the vultures are circling their prey. And then I'm walking in, and those cars are still driving around circles, waiting for someone to leave. As I walk into Costco, I get there faster. Oh, another thing that happens at Costco, everyone walks around and wanders around for half an hour. Yeah, let's get one of this. Oh, this tastes that. And then you go to checkout, and everyone wants to check out. What's the shortest line? Well, you just wander around for a half hour aimlessly, and now you want the fastest line, and you get frustrated because I'm checking out all my items. Anyways, distance, rate, and time. Time is money, I guess. Who goes to Costco and goes for one item and leaves?
Me.
What item do you get?
Not. I went there like twice already.
Tri-tip. Buy the tri-tip. Or meat, yeah. So you go in, get your meat, and get out of there. And then you get stuck behind someone that has 100 items, right? Or they take forever and they're talking to the cashier. Anyways. Hi, imaginary. So that's the case for imaginary numbers. And so I'm going to show you, like I started off with. I'm going to show you the quadratic formula and show you why I works. Okay, we're solving quadratics. So I'm jumping back and forth between this quadratic business and non-quadratics. I think quadratic that is, so which quadratic did I have? X squared plus, I think it was 6x plus 12. Oh, 4x. I'm trying to think. I think 2 solved that quadratic. 2 squared plus 4 times 2, 4. Oh yeah, 4x. 4x will work. So I'm gonna the first thing we're gonna learn is solve by factoring when we solve quadratics, but this is unsolvable. So one of the things we're gonna need to do is say that this does have a solution. It's an imaginary solution. We'll solve using a quadratic formula, and it goes like this. Negative b plus or minus square root of b squared minus 4ac. Okay, so we're gonna spend a lot of time on it later. So this is 16 minus 48. Divided by 2. 16 take, it's only punch, so I don't do this wrong. 16 take away 48. I want to make sure that I do this correctly. 32. So here's square root of 32. I can simplify square root of 32. 32 is 16 times 2. Remember that one? We did this back in chapter 1. 16 times 2 is 32. Well, the square root of 16 is 4 times the square root of 2. Okay. And like I said, we'll get to this quite a bit later. 4 times the square root of 2. Oh, it's negative. When I square root negative 16, that's 4i. So when I square root negative 32, let's do some side math over here. That's square root of negative 1 times square root of 16 times square root of 2. Okay, so square root of 16 is 4, square root of negative 1 is I, 4i square root of 2. Square root of negative 32 is 4i square root of 2. This is what x equals. This is solving a quadratic equation. Negative 4 plus or minus 4i times the square root of 2. All divided by 2. I want to simplify one more time for a specific reason. That quadratic is unsolvable. If I graph this quadratic, it does not intersect the x-axis. But there will be a solution. I'm going to divide that by 2, and I'm going to divide that by 2. -2 plus or minus 2i square root 2 is the solution. When I plug this back into the equation, I'm going to make 0. So this is one of the first things that you're going to have to do. You're going to have to say, is this complex number a solution to this quadratic equation? I like talking about mortgages a lot more. I'm just kidding. Any math, I get excited. So I'm going to substitute this back into the original quadratic equation. Let me show a side example real quick. X squared minus 2x minus 3 equals 0. X equals 3. 3 is a solution to that quadratic equation. That quadratic equation intercepts the x-axis at 3. And how do I know? I plug in 3 over here. 3 squared minus 2 times 3 minus 3 equals 0. Let's see if it works. 3 squared is 9. 9 minus 6 minus 3 equals 0. Is that a solution? Is 3 a solution? Did 3 solve that equation? 9 minus 6 minus 3. 9 minus 6 is 3. 3 minus 3 is 0. Check. It works. So that's a quadratic equation that is solvable. 3 is the solution. So I plug 3 in to see if it works. If this is in fact a solution to that, I'm going to plug it in to see if it works. Okay, this could be high level math. You're probably not going to have to do this, but on the homework, 2.4 homework, the first thing you got to do is plug I into a quadratic equation. Okay, plug in I. So I'm going to plug this I into here, right there where it says x squared. I'm going to do it down here. So x squared plus 4 Okay, I'm not sure if you want to write all this down. It's going to be some high level math. We're going to be squaring some complex conjugates, and we got to learn how this works first. So I always plug in the solution, -2 plus or minus 2i root 2, -2. I'm just going to do the plus, not the minus. 2 plus 2i root 2 plus 12 equals 0. So I'm going to square this. So I have to do the FOIL method. -2 plus 2i root 2. -2 plus 2i root 2. I just wrote it twice. I'm going to distribute 4. What did you do? Distribute property real quick. Let me write a minus. -8 plus 8i square root 2 plus 12 equals 0. So I got to multiply all that out. And again, you don't have to write all this down if it's like causing you fits. If you're having trouble with it, don't worry. Okay, we're gonna get to where this comes from. -2 times -2, 4. -2 times 2i square root 2 is -4i square root 2. Okay. Then we'll multiply this one times both of those. This one times that. Oh, that's -4i square root 2. Then I gotta multiply this times this. I'm just gonna write it out. Oh, it's positive 2i times 2i. 4i squared times square root 2 squared. I'm gonna put that in parentheses just because it's -8. 8i square root 2 plus 12. This is like magic. I like puzzles. I like solving a puzzle. I like solving things. But to me, this is a big old puzzle with a lot of foreign language. Okay. 4. Okay, -4i root 2 and -4i, they both have square root 2. I'm gonna add these together. 4, -4 and -4 is -8. I square square root of 2. Now I'm gonna, let me double check this one. I'll multiply 2i times 2i, 4i squared. I forgot the square there. Okay, 4 times I squared. So I squared was -1. I got 4 times -1. And then square root of 2 squared is just 2. Hopefully this works. All right. There's -8i root 2. There's positive 8i root 2. I'm gonna cross those off just right now because that's 0. Or, okay, this is negative 4 times -1 times 2 is -8. Did I do that right? Yeah. I squared was -1, -8, minus 8, plus 12, 0. 4 take away 8 is -4, minus 8, plus 12, 0. 4 negatives and 8 negatives is 12 negative. 12 negative plus 12 equals 0. Check. Solution. It worked. Yay! I didn't screw up this time. All right. So I just proved, what does that prove? Okay, it's a mathematical proof. I just proved I solved this using the quadratic formula, which we're gonna learn about. And then I plug it back in to say, hey, does it work? Okay, so I just proved that it worked. That's a complex. This right here is called a complex conjugate, or not complex conjugate, complex number. Okay, that's a complex number. When it has an I in it, it's a complex number. You probably are gonna deal with square roots of 2. That was extremely complex. That was a high level problem. I'm not gonna test you on a problem like that, but plug I into the quadratic equation. So like this. X squared plus 16 equals 0. Not a difference of 2 squares. 4i is a solution. How do I know? 4i solved this equation. 4i x equals 4i is a solution. So this is one thing you're gonna have to plug 4i in to see if it works. 4i squared. I put 4i here plus 16 equals 0. 4i squared, 4 squared is 16. I squared plus 16 equals 0. Well, we already established that I squared is negative. I squared is -1, right? 16 times -1, -16. -16 plus 16 is 0. 4i solved that equation. If I graph x squared plus 16 equals 0, it's quadratic. It does not cross the x-axis. The solution is 4i. So what's it look like? It looks like this. 16 is the x-intercept. I'm sorry, the y-intercept, 16. It intercepts the y-axis at 16. But how does 4i solve that equation? So one thing you're gonna have to do is you're gonna have to plug in imaginary numbers. And we have an imaginary XY coordinate plane. We have a real and imaginary coordinate plane. So instead of x and y, we have real and imaginary. So these are real numbers, these are imaginary numbers. So if I got 4i, I go 4 in the I direction. So this is I. I'm gonna go 4i. 1, 2, 3, 4. There's 4i. Where's 5 at? 1, 2, 3, 4, 5. Here's 5. Where's let me put it on here. 2 plus I. So go 2 in the real direction. So you always start at 0, 0. 1, 2 in the real direction. and 1 in the I direction. That's this location here. I'm gonna rise over run, I'm gonna run 2, rise 1. So this is 2, this is I. And I can do the math, and I can figure out 2 plus I times 2 plus I. I can use the Pythagorean theorem to do stuff like that. -3, I don't need parentheses, -3 plus 2I. So I'm gonna go 3 in the real direction from the left 3, and go up 2 in the imaginary direction. Left 3 and up 2. Put a dot there. So this is graphing in an imaginary coordinate system. And you're like, why are we doing imaginary numbers? What does this have to do? I just showed you that it proves quadratics. Okay. That complex numbers can prove or show that this quadratic has solutions. Because in math, there's an answer for everything. Okay. Down here, -4 minus 3I. So go 4 in the real direction. 1, 2, 3, 4, and down 3. 1, 2, 3. So it has to do with quadrants. Quadrant 1, 2, 3, 4. It's a positive quadrant. Which is when this axis is negative, this axis is positive. So it's got the same kind of quadrant set. So you might have to graph. You might have to graph an imaginary coordinate. Let me go back over here. Let's see, we did this. We did graphing. And within all that, we did substitution. Okay, we did substitution. That's what I did over there. Want to do let's do an easier one. I'm gonna let you work for like a couple minutes. I'm gonna give you one of the problems. It's 5 through 47 odd 2.4. Let me grab one real quick. Everybody has this right here. Can I erase this? Yeah. Avoid the mess. That's what in math they have a saying. Avoid the mess. Okay, here's the mess. So I got, this is number 5. This is the first problem on your homework. So go to your homework section, or wherever you do homework, and we're gonna do the first problem on the homework. So y equals x squared plus x minus 4. And the solution is 2i. And it says evaluate for I. So what you're gonna do is you're gonna substitute, this is the substitution part, plug 2i in for x and see if it solves. See if we get 0 as a solution. All right, so 2 minutes, you can talk it over, raise your hand, we'll walk around, try to get to you if we can. Alright, so we plugged in 2i. Did we get 0 when you plug 2i in? Does it make 0? Y equals 0. So we got y equals 2i squared plus 2i minus 4. So you could say I is the square root of -1, but I is just I. So look over there. If I got a 2i, I need a negative 2i somewhere. If I got 2i, I need a negative 2i somewhere. Well, there's 2i. But 2i, oh, I forgot my parentheses, sorry. 2i squared, so we squared the 2 and squared the I. 4 times -1 plus 2i minus 4. That's -4 plus 2i minus 4. Then I can put these together. -8 plus 2i. Usually when imaginary numbers, it's kind of weird. When I have x's and numbers together, x plus 2. We usually don't write 2 plus x. We write the letter first, the number second. But with imaginary numbers, I didn't come up with it. Customary is to write the imaginary number second and the whole number first. I can't tell you why right now, okay? But that's the solution. Y equals -8 plus 2i is the solution. And we could graph that in the complex coordinate plane if we want. So where's 2i at? Where's 3i at? I can find that solution. Where's 4i at? I can find that solution. Where's 0 at? 0 is at -4. So you can put plots all over this complex graph, and you can graph it in a complex coordinate system, and it'll make a picture. Okay, but that's beyond the scope of this class. We're just seeing if it's a solution. So that's what you got to do for 5 through 10 on your homework. Cool. Just plug it in. So we got in a little addition there. We're adding. I showed you a little bit of addition of complex numbers. So we add them just like letters, like 3i plus 4 plus I minus 2. You just add them up, okay? 3 i's plus 1 I makes 4i. +4 plus -2, +2. Okay, when you add complex numbers together by like terms, that's the operation that we typically use. 4i plus 2. I simplify. How about subtraction? 3i plus 4. Subtract. Let's take away. Okay, so remember, order of operations, add, subtract, multiply, divide. We gotta follow the operations first. I gotta distribute the negative sign times those. It's like -1. If there's a negative out here, I gotta subtract I and subtract -2. The opposite of -2. So I gotta do 3i plus 4 minus I. I can't just subtract I and not subtract 2. So -2 plus 2. That's addition and subtraction of complex numbers. Cool. Put these together. That's 2i plus 6. Completely different answer. If you get the same answer, you probably did something wrong. So add and subtract imaginary numbers. What about multiplication? Let's multiply them together. Well, we already did a little bit of multiplication over there. Like, where did all this business come from? Okay, I went pretty fast with that. Some of you are probably like, okay, slow down. All right. So here we go. We're gonna multiply imaginary numbers together. So add, subtract, multiply. 2i times 3i. So again, multiplication is commutative. We can change the order around any way we want. 2, we multiply the numbers together, the 2 and the 3. So I can do 2 times 3 times I times I. 2 times 3, I multiply the numbers together and then multiply those together, I times I squared. Well, what's I squared? Oh, we're gonna use substitution now. I squared is something else. We have to go back to our notes possibly. I squared is a whole number. -6. 2i times 3i is -6. Okay, and this will all make sense when we start solving quadratics, when we do, like I did all that quadratic business over there. Multiply, so these are complex numbers, but they're not. They're basic complex numbers, a super complex number, 2 plus I. So here we go, now you're really gonna get into it. 3 plus I. Put a curly on there. 2 plus I and 3 plus I. So you're gonna work on this, very distributive property, I kind of showed it already, we've done this chapter 1, distribute here, or FOIL. Okay, or use the box method to multiply this out. Let's go ahead and do that. So 5i plus 5 or 5 plus 5i. Yeah. Okay. So these are similar. Okay, now we're gonna multiply 2 of them, they're called complex conjugates. Okay, remember I mentioned that word last week, the conjugate. And we had one where it's like, oh, you gotta multiply by the conjugate. You cannot have I in the denominator. Okay, in order for it to be a complex number, I can't be in the denominator, so you gotta multiply by an I, then remove an I in the denominator. The way to do that is multiply by the complex conjugate. So like 3 plus I. The opposite of that is 3 minus I. 3 plus I and 3 minus I. Magic happens when you multiply these together. Pretty cool. It's like a puzzle, piece of the puzzle. Something happens. See if you can figure out what happens when you multiply these two together. So go ahead and multiply those two together. Try that out. Was everybody able to get to that first step? Yeah, double check and make sure you got that. The trick one is the negative I squared. So that's an important concept right there, negative I squared. Run out of room. More board space. Yeah, 9 minus I squared. Am I done? Can I keep going? When do I stop? What's I squared? Negative 1. That's a trick. Oh, 9 minus I squared. When you ever see minus I squared or negative I squared, the light bulb needs to go off. Okay, it's the first time you've seen it, but negative I squared is a whole number. 9 minus I squared is minus negative 1. I substitute this right here is negative 1 minus, there's 9. Yeah? Minus negative 1, that's the opposite of a negative number is a positive number. Then that just blows my mind. How you can multiply and add all these negative numbers, these complex numbers together, you get a whole number answer. And I left that up there for a reason because I square root of 2, you'll end up canceling I square root of 2. And we did it right there. I squared was negative 1. And that worked out to be negative 8. Oh, so it was a whole number answer. So complex solution and solve quadratic equations. Right? So you don't run into physics real life problems. You don't run into complex solutions too often. But there is a solution when you have no solution. Okay, most time you solve it, you're like, no solution, but there is a solution. Okay, and this is most useful when you have I said there's an I in the denominator. When there's an I in the denominator, we can't have I's in the denominator. So this is division of complex numbers. So we did add, we did subtract, we did multiply, and here's the last one, divide. And then we're gonna go to town for about 20 minutes on 5, 3, 47 odd. Okay, so now we divide complex numbers. 7 plus 2I divided by negative 2I. So in order to eliminate the I in the denominator, this is dividing by imaginary numbers. It can't have an I in the denominator. Just say no, can't do it. Okay, can't divide by imaginary numbers. Can't divide by 0. But there's a solution to this. In order to get rid of the I, we gotta multiply. We gotta multiply by the opposite of this. The opposite of negative 2I is positive 2I. Okay, it's kind of like doing this. Okay, this is not simplified because there's I in the denominator. In order to simplify it, we have to multiply by its conjugate. Just like this, if you have 1/2 multiplied by 3/3, that's the same thing as 3/6. So we're just going backwards. Instead of simplifying to a simplified fraction, 1/2, we're just multiplying by 1. This is 1. 1 times any number is 3/3. That's 1/2. Okay, so we're just transforming it. Transformer. When you divide by imaginary numbers, you multiply by the opposite or the inverse. I'm going to multiply this out. I put parentheses around that. 7 plus 2I times 2I. It might be backwards. It's all right. You can still distribute. And negative 2I times positive 2I. That's negative 2I times positive 2I. Yeah. Losing anyone there? Alright. Let me continue this, I'm going vertical, I'll do vertical math here. 7 times 2. And it's 7 times 2. 2i times 2i. Four I squared, yeah. You might think they cancel, but they don't. Because we have a positive 4i squared. You can skip steps. If it's starting to make a little bit of sense, right here, you could have skipped that step, but I just want to show where it comes from, okay? And 4i squared, where I squared is -1. I'm running out of room. 4i squared, I squared is -1. I'm gonna skip a step right now. -1 times 4 is -4. 4i squared is -4. Oops. Sorry about that. 14i minus 4. This is -4. Okay, we went through that earlier. -4i squared. So -4. Can I simplify anymore? I think I can. That's simplified, but I see a factor. All these have a factor of 2. And divide out a factor of 2. We'll do this a lot more later when we get to quadratics. We actually did it over here. When I solved it up here. Okay, I can factor it out, or I could write it like this. I'm gonna divide everything by 2. Okay, so 14 divided by 2 is 7i. 4 divided by 2 is 2. And 4 divided by 2 is 2. Does anybody want me to show you how you go from here to there? You may need to see that. Yeah, why not? Okay. So there's many ways to go through that. There's 14i minus 4 over 4. I'm going to factor, we're a GCF factoring. They have 2 in common. So 2 divided by 4 is 1/2. Or 7i over 2. That's one way. Or you write it as 2 separate fractions. 14i over 4 minus 4 over 4. That's 7i over 2 minus 1. But we don't like fractions. This is equal to that. Because 7i over 2 minus 2i, or minus 2 over 2, there's your 1. So we could write, this is customary, this is the best way to write it. That's more complicated than this thing. Okay, I like this much better. But like I said, when we solve quadratics a little bit later, we'll get to that. We still have an hour and 21 minutes, believe it or not. Oh my God, you got a level there. So I'm gonna give you like 20 minutes, plenty of time to try to get through and start working on some stuff, apply what you learned so far. Break time, take a walk about. Use the restroom, you need to, but try to get in some problems 5 through, very number 5 through 47 on. Ooh. So 49, distributive property, that's not the answer, remember, it's substitute. I raised the 7th power is negative I raised the 9th power. I, yeah. So it's just negative I plus I.
0.
0. There you go. That, all that is like 0. It's like, are you serious? Pretty funny. Hey, 0 is an important number. 0 is a very important number on the XY coordinate plane. We graph horizontal lines. Okay, a horizontal line, we're a y equals mx plus b. Y equals 4. Well, there's no x. There's no x here. This is a line with a slope of 0. We're ringing the bell last week, yeah? Slope of 0, y equals 4 has 0 slope, horizontal, flat line. So I'm gonna go to y equals, this is y equals 4. 1, 2, 3, 4. There's y equals 4. Okay, that was just a review. Y equals 4. Y equals -2. Go down to 2. Some students like to put a dot there. Okay, it's not an intercept, it's an actual line. Okay. Horizontal line. How about this line y equals 0? This is an important thing. Y equals 0. We don't usually write those things. Y equals 0. A line that has a slope of 0 and has a y-intercept of 0. So if this is 1, this is 2, this is 3, this is 4. There's -1, -2, -3, -4. Well, 0 is right in the middle. This line, y equals 0. Y equals 0 is the x-axis. So when I graph a quadratic equation, a quadratic, okay, these are parabolas. We're not really graphing right now. We're just solving quadratics, okay? We'll get into graphing quadratics a little later. So a linear equation, a straight line, is a linear equation, a line. Quadratic equations are these curved parabolas. So when I graph a line, I graph a line like this. This is a quadratic. This quadratic has a x-intercept of 1 and 3. X equals 1. X equals 1 and 3. 1 and 3 are solutions to that quadratic. It has a y-intercept of 3. Okay. X equals 1 and x equals 3 are solutions. So I want to work backwards and figure out these intercepts. So if I work backwards, okay, I'm going to write it like this. X minus 1 times x minus 3 is going to be equals to 0. Well, when y equals 0, that is the x-axis. This x-axis is y equals 0. Right here where I put a 0 at is an important number. 0 is an important number. This is y. So x minus 1 times x minus 3. If I solve this equation, x is 1 and 3. I'm going to distribute. That's x squared. Just ringing a bell, multiplying binomials. Okay, this is why we multiply binomials. In order to solve quadratics, everything we do in algebra is because we got to do more math, right? There's -1x. And -1 times -3 is +3. Equals 0. Oh, like terms. Put like terms together. X squared minus 4x plus 3 equals y. 0 is y. Y is 0 for a quadratic equation. So this is a quadratic equation we can solve, but when you put 0 in for y, that means we're gonna solve and find the x-intercept. If I put y over here, we saw one like this earlier. It said y equals. If I go in my graphing calculator, let's go ahead and do this. If you have your graphing calculator, you can pull it out. Or if you have your computer, you can go to Desmos. So we're gonna do both. We're gonna press on our calculator y equals x squared minus 4x plus 3. We're gonna graph this quadratic. Y equals x squared minus 4x plus 3. And we see the parabola. Did everybody get it? So make sure you put minus and not negative. Yeah. X squared minus 4x plus 3. Everybody got it? And you can zoom in or just look at it and verify. The x-intercepts are 1 and 3. 1 and 3 are solutions. 1 and 3 are solutions to that quadratic equation. This quadratic equation has those two numbers as solutions. The y-intercept is positive 3. That number right there is the y-intercept. How do I know? When x is 0, plug 0 in here and 0 here, y equals 3 when x is 0. I could write it as coordinates. 0, 3. When x is 0, y is 3. When y is 0, x is 1, and x is 3. There are two solutions. Quadratics always have two solutions. Linear equations always have one solution. And a solution, this word solution, has many meanings. Solution to a quadratic. Solve it. If I write them as coordinates, x equals 1 and x equals 3 are solutions. As x-intercepts, I'm going to write them as points. Okay, if they're x-intercepts, I'm going to write them as points. 1, 0, and 3, 0. The coordinates on this graph. These points are also called, roots. Roots of the quadratic. Okay, so this whole entire graph stems. Okay, these are like flower in scientific terms, a stem or a root of a tree. The tree grows from the roots, right? Gotta have roots for a plant or a flower to grow. So these are the roots to the quadratic equation. They grow the quadratic equation. They originate from those roots. That's what solving quadratics is all about. So whenever you see y equals and it has an x squared, and it says y equals x, there's one solution. It says y equals x squared, there's going to be two solutions. How do you solve quadratics? You solve by factoring. If I take this x squared minus 4x plus 3 and then factor it, 3 times -1 is positive 3. Remember the middle terms, -1x and -3x make -4x. Those two numbers right here are called, these are called factors. These two numbers are called the factors. These two numbers up here, +1 and +3 are solutions. Well, what do you notice? What do you wonder? I noticed that the factors are the opposite of the solutions. So I'm going to take a quadratic. Take a quadratic. Y equals x squared. I'm going to leave it like that. Y equals, I'm in y equals form. It's bad news. I'm marking right now. Y equals x squared minus 5x minus 6 is a quadratic. I can graph it. I can solve by graphing. Hey, that's easy. Go to Desmos. And we can always check our answer. Go to your graphing calculator. Graph y equals -5x, or y equals x squared minus 5x minus 6. Let's graph it and solve by graphing. And tell me what x equals. Okay, again, we're solving by graphing. We graph it. And we're gonna find the solutions. What are the solutions? Anybody get them?
And
6 and -1, or -1 and 6, either way you write it. Did everybody find those? The y-intercept is -6. These are the solutions. These are the roots. Okay, and we often use those names interchangeably. Those problems, those numbers solve that quadratic. How does it work? Well, we're gonna do our first method of solving quadratics is by factoring. So when we get solutions, our first method of solving quadratics is to factor. There are 3 methods of solving quadratics. We can, this is using algebra, we can factor, we use the quadratic formula, or we can do what's called completing the square. Okay, so we're learning how to use, we're gonna learn all 3 of those in the next 40 minutes. We're gonna solve quadratic, we're gonna solve that. So factoring is first. So I know that those are solutions. Let me do this right down here. So first step to factoring, I got put 2-step. Remember we did this, the factoring. I believe this was 1.3, we did factoring. I need 2 numbers that multiply, these are the magic numbers, 2 numbers that multiply to make -6. So here's our multiplier, multiply. I need 2 numbers multiply to -6. I got 2 and 3, 6 and 1. Those are the numbers. 2 and 3, 6 and 1. I can do a diamond. -6 and -5. What numbers satisfy that? Most people think 2 and 3. 2 times 3 is 6. 2 plus 3 is 5, but these symbols right here are important. 2 plus 3 is +5, doesn't work. What about -2 and -3? Ooh, we might think that works. -2 and -3. -2 and -3. -2 plus -3 is -5. But when you multiply those 2 numbers, that makes a positive. That's a different quadratic. That doesn't work. 2 and 3, -2 and -3 do not work. So this is kind of like a guess and check. How about 6 and 1? +6 and -1. 6 take away 1 is 5. Oh, that doesn't work. I did all those other ones on purpose instead of giving you the answer right off the bat. So 6 has to be negative. And 1 has to be positive. -6 times negative, or -6 times 1 is -6. -6 plus 1 is -5. Those are the magic numbers, -6 and +1. -6 and +1. Again, these numbers are called factors, like I mentioned over there. These are the factors. They're called factors. We use something called the zero product property. Another name for this, these are also called zeros. Did I put an E on there, like Zorros? Some people write like that, put apostrophe there. Okay, they're also called zeros. Why are they called zeros? Because when y equals 0, I could use the zero product property and say x minus 6 equals 0. And x plus 1 equals 0. We got 2 linear equations. This is linear and that's linear. So x minus 6 equals 0, we go +6. X equals 6. Subtract 1 from both sides. X equals -1. There's your solutions. We solve graphically. This is called solving algebraically. Factor. We factor. We factor to solve the quadratic. Those are solutions. The zeros Using, it's called the property that I used to break this into two parts. The actual name of it, you might see it, zero product property. Okay, let's do practice. Let's do practice. Where should I put it? Not a space. Oh, I got a little space over here. So factor. Solve by factoring. So it's called solving a quadratic. You ready? Simple. So you're gonna find the factors and then you're gonna solve. And we can check with the calculator. If you have a trouble, talk it over, raise your hand, phone a friend. Ask the audience. You can do all those things. So has to be 4 and 2. I knew 4 and 2 is 4 times 2 is 8. I knew it had to be 4 and 2. If you try positive numbers, 4 plus 2 is 6. That's not 6. If it was plus plus, that'd be a 6. That's a different quadratic. So one has to be positive, one has to be negative. Plus and minus. 4 is positive. Again, these are called the factors. We factored it. What are the solutions? So x plus 4 equals 0. X minus 2. There are 2 solutions to quadratics. I'm ready to switch my pen out. Subtract 4 from both sides. Add 2 to both sides. These are called the solutions. We solve the quadratic solutions. And what do you notice? They're the opposite. The factor is 4, solution is -4. The factor is -2, solution is +2. They're the opposite. So I mean, at some point you can skip this step. Unless you have a quadratic that looks like this. You factor 2x squared plus 5x plus 3. And you end up with 2x plus 3 and x plus 1 equals 0. So you can't just say, oh, the answer is -3. You can't go, oh, it's the opposite of 3, because 2x plus 3 equals 0. So I gotta subtract 3 and divide by 2. 2x plus 3 equals 0. So you end up with a fractional answer. Not always will you have full number answers. Because on this, We're just dealing, I was just dealing with whole number answers. 1 and 3 are solutions. Well, what if you have a quadratic that has a 1.2 and 2.1 as solutions? Can you do that? Yeah. You have a quadratic 2.1 and 1.2 solutions. You have a quadratic with negative 0.9 and positive 3.7. Those are solutions. What if you have a quadratic that's unfactorable? Ooh, no solution. Okay, what does it look like? Looks like this. No solution. Oh, we're gonna do complex solutions. If it looks like that, we're gonna have complex solutions. So we're gonna learn to solve quadratics that have complex solutions in a few minutes, but we're gonna solve by factoring. So I'm gonna let you go to work on factoring 2.5. Solve by factoring. Yeah, so it's 6 through 16. I have you solving all of these by factoring. There's some tough ones in there, but 6 and 7 are similar to 6, 7, and 8 are similar to that. So we're just try 6 through 8 right now on we're on 2.5. 6 through 8. So I'm gonna give you like five minutes to see if you can do some factoring, okay? It has 2x squared plus 9x minus 5. There's actually 4 options for this, so it's a guess and check. So 2x squared plus 9x minus 5. We can't just go, oh, 2 numbers multiply and they make -5 and add to make 9. Well, we got an extra factor of 2 in there. So when this is a quadratic term, the coefficient of the quadratic term, when the number is greater than 1. So if you remember factoring, when it's 1, we can use the diamond. Like we did all those 3. Those are all factorable. This one was more complicated. There's a factor of 2. Okay, so that's what happens with number 8. You have the extra factor of 2. 2x. Oh, there's 4 options. Well, why are there 4 options? 2x plus 5 and x minus 1, what does that make? That makes 2x squared plus 3x minus 5. That's not it. Well, if we try 2x minus 5 and x minus 1, that's 2x squared minus 7x. Oops, I wrote the wrong thing again here. Why I left my coefficients off all of these. I'm sorry. 2x squared minus 7x plus 5 equals 0. That doesn't work. This one, this is 2x squared minus 9x minus 5 equals 0. That's really close, right? We're off by a negative sign. This is 2x squared minus 9x minus 5. We need that. So it's the last one. These are the 2 factors of that. This is 2x squared plus 9x minus 5. Multiply 2x, we're going to distribute 2x squared plus 10x. And then -1 times that, -1x minus 5 equals 0. So those are the factors, not the solutions. These are the factors. How do you solve that? So that's like the one that I showed earlier. 2x minus 1 equals 0. And x plus 5 equals 0. So we got to solve those 2 linear equations. What I did there was called zero product property. 2x minus 1 equals 0. Add 1 and divide by 2. Close to half. And again, you can check. Every one of these you can double check when you're taking your test. You're allowed to use calculator graph on your calculator. I showed how this. That's what I started with. Graph 2x squared plus 9x minus 5. Press y equals. Y equals 2x squared plus 9x minus 5. Find out the x-intercepts. One x-intercept is 1/2 or 0.5. The other x-intercept is -5. Okay. I know for sure. I'm 100% sure. That those are the intercepts. It's gonna look like, that equation right there is gonna look like this. Okay. It's going to have an intercept of +1/2 and -5. Gonna have a y-intercept of -5, so I'm gonna go down 5. 1, 2, 3, 4, 5. And it's gonna be a quadratic. It's gonna be really steep. It's gonna go down really low, come back up, because there's a scale factor of 2 there. I can actually find the vertex. It's called the vertex. We're gonna graph quadratics later on. I'm gonna show you how I got that graph later on. But when we graph it, it looks like that. It probably goes off the chart. You probably only see this part when you graph it. Okay. But all these quadratics up here, you can graph all of them. To find the solutions. You can solve by graphing. Okay, but that's not what you're gonna be tested on. You're gonna be tested on solving by factoring. So it's gonna say solve by factoring. So the method that I would use, solve by factoring, what I wouldn't do is, I wouldn't do this. I would say, oh, solve that by factoring. I wouldn't give you the solution. I would give you which one of these are the factors. So it'd be multiple choice. It'd be A, B, C, or D. So you can always work backwards. You can always multiply it out like I did over there. Right? But what one of these are the factors to that quadratic? Yeah, so that's solving by factoring. Not every quadratic is factorable. And we encountered some quadratics. Well, oh, those are the complex ones. But sometimes quadratics, that one's factorable. What if the quadratic's not factorable? We have to have other methods of solving quadratics. These 3 quadratics right here, they are factorable, but we have other methods. They're factorable, but we have other methods. I'm going to show you how to factor, but I'm going to show you another method. This is called taking the square root or finding the DCF. Okay, the DCF is a part of factoring, but they're special factoring. What do I notice about these? There's no x term. A quadratic usually has x term. Okay, this is what I mean by an x term. 9x. There's a coefficient in front of the x. Well, those ones don't have an x. X squared minus 16 equals 0. This is like x squared plus 0x minus 16. The x term is 0. There isn't one. How do I factor that? Okay, this does have factors. I need 2 numbers to multiply to make -16 and add to make 0. It is factorable. So 16, 4 times 4, you pop into your head. 16 is 4 times 4. 1 is positive, 1 is negative. How does that work? 4 times -4 is -16. Oh, and I add these together. 4 take away 4 is 0. There's that 0 term. So those are the factors. There are 2 solutions. X equals -4 and x equals +4 are the solutions. If I graph that quadratic, or this quadratic, I get x-intercepts of -4, 0, +4, 0. I get a y-intercept of -16. So, does it say? There's gotta be another way to solve it. And there is. Whenever you have no x term, there's another shortcut. When x squared minus 16 equals 0, or y equals x squared minus 16, I can solve that equation without factoring. And this might be something you want to do. When I get to rookies, I call them rookies, 9th graders in this class, 9th graders in Algebra 1, you're 15 years old, and you just got done solving this problem. 2x plus 3 equals 7. So what am I going to do first? I'm going to subtract 3 and divide by 2. Yeah? I see that equation. I'm gonna go, oh, y equals 0, I'm following what Mr. Silva said, okay. So, like I did here, subtract 3 from both sides, I'm gonna subtract 3 from both sides. X squared plus 4x equals -3. So there's no real method of smashing these two things together. X squared plus 4x, I cannot add them together, though some people want to call this 5x squared. But that's not a square, right? It's not 5x squared. There's got to be a way to solve that, and there is. Called completed square. So I could solve this by doing a method, I call it the square root method. Okay. Oh, by the way, x squared minus 16 is called a difference of 2 squared, x plus 4 and x minus 4. They're a difference of 2 squared. Remember that factor? Or I can go like this. Since there's no x term, I can go like this. The only problem is there's two solutions, positive 4 and negative 4. When I square root, I get x equals 4. Well, where's the negative 4 at? So when you solve these without factoring, most sane people forget that negative 4 is a solution. Okay, so mathematicians are usually insane. They go, oh, we gotta find some way to do this. Whenever you square root both sides, I gotta add and subtract. I got a plus minus. Plus minus. Well, that all that means is x equals -4 and +4. The plus minus symbol is a new symbol. We're gonna use quite a bit. +4 and -4. So plus minus, if you've never seen that before, that just means there's two answers. One's positive, one's negative. Let's check, see if it works. Plug in 4. 4 squared is 16. 16, take away 16 is 0. It works. Remember the first thing that we did? Plug it in, see if it works. Plug in -4. -4 squared minus 16 equals 0. -4 times -4 is positive. Oh, a negative number squared is positive. 16 minus 16 is 0. So whenever there's no x term, we could use that square root method. Add 50 to both sides. 2x squared equals 50. So you're going to see some problems that look similar to this. X squared equals 25. Square root both sides. I could have factored that. I'll show you how to do it in 1 second. X equals 5 and -5. I could factor out GCF. 2x squared minus 25 equals 0. 2 cannot equal 0, so we kind of just ignore the 2. Difference of 2 squares. So x equals -5 and +5. X does not equal 2. That's not x equals 2. So x is 5 and -5. I got another one. In fact, kind of do what I did right there. Factor out this. Oh, that has an x. See how it's different than those? Those don't have x's. So I have to use a different map. I gotta factor it. What are they? Oh, common factor. They got a 3 in common. Factor out a 3. They both have an x in common. So a lot of factoring and solving by factoring is recognition. I recognize they both have a 3 in common, they both have an x in common. Well, like I said, I will tell you, factor by GCF factoring or solve by GCF factoring. It is common factor. Okay. Divide by 3x, we got x. Divide by 3, I got 25. When I divide that by 3. So 3x equals 0. I have 0 product property. And x minus 25 equals 0. Those are the factors. Divide by 3. 0 divided by 3 is 0. 0 is one of the solutions. The other solution is add 25. Right, like I've been writing. X equals 25. Okay, so there's 3 different, like, unusual, you don't see those that often. Unusual factors. But what if quadratics are infactorable? That was the big question. Then, all these are factorable, let me see. Let me get one that is not factorable. Let me get rid of that 5 right there. Let's go like that. 2x squared plus x plus 3. 2x squared plus x plus 3. That's unfactorable. What if your quadratic's unfactorable? Then I gotta have another method of solving quadratics, and that's called the quadratic formula. And the quadratic formula comes from completing the square. I'm gonna show you how to complete the square. Okay, so sometimes we can factor, all of these are factorable. But I'm gonna show you the same solution, 6 and -1 are the solutions, I'm gonna leave them up there. But I'm gonna show you how to solve by completing the square. Completing the square, let me give you some steps. Okay, just like steps for writing a linear equation, these are steps to complete the square. I was gonna get an 80s reference. You guys familiar with the 80s music? It's hip to be squared. That was the song. Huey Lewis, I think, one of those guys. Hip to be squared. Oh, it's hip to be squared, not when you're completing the square. So we're talking about perfect squares. So this completes the square. I'm not gonna go into the symbols, symbolism and all that stuff. Steps to complete square. One, we're gonna get x squared and x together. I'm gonna get rid of that. Step 2. I'm gonna find half of b. Step 3, I'm gonna square it. And then step 4, I'm gonna solve for x. Oh, it's 4-step process, just like writing, I try to stick. There's steps within steps here, but I'm gonna go to that second one right there. And remember, when we solve quadratics, we want it to be y equals 0. So I'm gonna solve that quadratic. I'm gonna get the x, I'm gonna follow the steps. Okay, so let's use this example here. I'm gonna get the x squared and the x together. Get the x squared and the x together. So that means I'm gonna subtract 3 from both sides. Okay, this quadratic right here is equivalent to that quadratic. They're the same thing. Okay. So I got the x squared and the 4x together. Okay, most quadratics are in the form ax squared plus bx plus c. Okay, so the b term is the term that's next to the x. That's the b term. Okay, not a linear equation. So I'm gonna do half of b. Find half of b. Half of 4 is 2. Half of 4 is 2. So I'm gonna go x plus 2 squared. X squared plus 4x is not equivalent to x plus 2 squared. It's similar. Okay, these are similar to each other. What I'm missing here is a plus 16. All right, I'm sorry, not plus 6, plus 4. This is not equivalent to this. X plus 2 squared is, I'm gonna write it out. That is this. So I distribute, I'm gonna get x squared plus 4x plus 4. I'm missing a plus 4 up there. So what I'm gonna do is I'm gonna do what's called balancing the equation. I'm doing vertical math. So we talked about horizontal math, we're gonna do vertical math. So what I gotta do to make this equivalent to that is I gotta add 4. I gotta add 4 here. This is equivalent to that. So if I add 4 on one side, I gotta add 4 on the other side. So I said horizontal math, okay? Complete a square. Little process. So I found half of b and I squared it. 2 squared is 4. I gotta square it. and add to both sides. So step 3 is a 2-part problem, add to both sides. So I'm doing I'm doing sideways math and vertical math at the same time. I can do this math, 4 minus 3 is 1. It's kind of funky. Why don't we just factor? Okay, you might have pointed out the obvious, well, factoring is way easier than completing the square. But completing a square solves quadratics that are unfactorable. Sometimes you can't factor. Okay, like we did right over here. Okay, right here. I got x squared. In order to find the inverse of x squared, I'm going to square root. Here's a square. In order to solve it, solve for x. I got a square root. That's the part of solving. I wish I had different colors right now because I'm going to square root both sides. Square root both sides. When you have a square right here, you square root both sides. But remember, we got to introduce that plus minus. When you square root, I get plus minus. The square and the square cancel each other out. I call this the double knockout, like in boxing. At the same time, the square and square root double knockout, they kick each other out. So I'm left with x plus 2 equals plus or minus the square root of 1, which is 1. Okay, I'm going to switch the sides because we're used to having x on the left and this on the right. I'm just going to switch where these are at. And I'm going to solve for x. I'm going to get x by itself. -2, x equals -2 plus or minus 1. -2 plus 1. -2 plus 1 is -1. There's 2 solutions. -2 minus 1. 2 negatives and 1 more negative is -3. Remember the original solution, this problem is the same problem we had earlier. We solved by factoring x plus 3 and x plus 1 were the factors. X equals -1 and -3 are the solutions. So I could have factored that and solved, but that's completing the square process. The completed square only works really well when the second number is an even number. 4, 6, 8, 10, 12, 2. Okay, when that second number is a even number, it works really well. When the second number is odd, we end up with fractions because I got to find half of 5. Half of 5 is 5 halves, or 2.5. Then we get into some crazy math. I'll get to one of those probably tomorrow when we'll do one like this tomorrow. Okay. But I'm going to go ahead and complete square for this. I'm going to go through it real quick. I got to get one more thing in. 0 equals. All right. Let me get the x squared and the x together. So I just move that 8 over there by plusing 8, and I turn the y into 0. When y is equal to 0, that's called solution. Okay. Half of b. There's half of b. Square it and add. So I'm going to square 1. 1 squared is 1. I'm going to add 1 to both sides. That's a process. What I just did was complete the square. That's this complete square process right there. Now I'm doing vertical math. This x squared plus 2x plus 1 is equal to that. They're equivalent. So 1 plus 8 has to be equals to 1 plus 8. There we go. Crazy math. Square it and add to both sides. That's the complete square. This part right here. That's the complete square. Then the rest is solve for x by doing the square root. Do the square root. Do the mashed potato. I don't know. I think of songs when I think of math. I don't know. Square root and square cancel each other out. Whenever you square root, you got it plus minus. The square root of 9 is 3. I'm gonna switch the sides, put the x on the left. The x plus 1 on the left, and put the plus minus 3 on the right. Subtract 1 from both sides. -1 plus or minus 3. So that might be a new symbol for you. Plus minus. This means I'm gonna write it both. -1 plus 3. I kind of did in my head earlier. -1 minus 3. -1 plus 3 is, this is 2. -1 minus 3, 1 negative and 3 negatives is 4 negative. The solutions are 2 and -4. So that is complete and square. Again, factoring is easier, so I better learn how to factor. Factoring is really important, especially when you get into physics and higher level math, pre-calculus, calculus. Okay, higher level math, you got a lot of factoring going on. Factoring is way easier than completing the square. Completing the square is a long process, but from completing the square, we can generate the quadratic formula. And the quadratic formula is the best method. Completing the square is a long process. The quadratic formula, we're just gonna plug in numbers. So give me like 4 more minutes, and then I'm gonna show you the quadratic formula, and then we'll continue this again tomorrow. I'm gonna go back to that. So -1 and -3 are the solutions. I need to get rid of something here. The third method of solving quadratics is called the quadratic formula. And I'm gonna derive it for you. Not tonight. The derivation of the quadratic formula. Take some time. So if I have a quadratic, ax squared plus bx plus c. So it goes a, b, c. So we got a, b, and c. So remember, b is the term next to the x. If I solve for x equals -b plus minus square root b squared minus 4ac, all underneath the square root sign, which is all divided by 2 times it. So I'm just gonna go through. Let's do 2 of them real quick. So real fast. So I'm gonna take this one. We solved this one by factoring. We solved this one by graphing. Solved it by factoring. We solved it by completing the square. And now we have to solve it by quadratic formula. That formula right there. So it's all substitution. It's all substitution. X equals. I'm gonna solve. I'm getting x. Quadratic formula smashes the x's together in a way. So I cannot add those together. X squared and 4. So what I'm gonna do, I'm gonna do -b plus or minus square root of b squared. All I need square root sign. Sorry, I'm writing small. So we're just plugging it in, and then we're gonna do math that we already know. 4 squared is 16. 4 times 1 times 3 is 12. All divided by 2. I got -4 plus minus square root of 4. All divided by 2. This is some magic as well. -4 plus or minus, oh, that's 2. How does this equal that? Well, it does. -4 plus 2. -2 divided by 2, which is -1. -4 minus 2 is -6 divided by 2, which is -3. Again, that's a lot of math. That's some complicated quadratic formula stuff. So is the complete the square, but factoring is easier, right? Factoring is a 2-step process. Find the 2 numbers that multiply to make 3 and add to make 4 and solve. So factoring is best. I would say factor everything. Oh wait, some quadratics are not factorable. That's not factorable. How do we solve that? This has complex solutions possibly. Let's find out. X equals -b. Oh, that's like a 1 right there. Plus or minus square root of b squared. minus 4 times A times C. All divided by 2 times A. One squared is 1. Oh, negative 4 times 2 times 3. That's 8 times 3. Oh, it's negative 24. 1 minus 24 is negative 23. Oh, there's a negative underneath the square root sign. No solution. Well, not no solution. It has complex solutions. Whenever you have a negative, that's going to be an I. Negative 1 plus or minus. That's I. Negative 1. I square root 23. So you might run into those with complex solutions. All that means is this quadratic, I tried to graph it, does not cross the x-axis. The first problem that we did, okay, when I showed where the quadratic formula, we did that imaginary thing. Remember in the very beginning, it took up this side of the board. It looked like that one, right? So that's what I started off with. If we plug this back into x right here and right there, I will get 0. Okay. Amazingly, it will work. Systematically, it should work. All right, thank you very much.
Thank you.
Did I do about? All right.
And for tomorrow homework,
One day you'll be able to do it. Oh yeah, so homework today, 6 through 16, 19 through 41 odd.